Welcome, everybody. Wow, we got a packed room. It's really, really good to see it. Thanks for coming to Next. Thanks for staying late. Looks like there's a lot of interest in Service Mesh. My name is Amir Abbas. I'm one of the product managers who work on Service Mesh. With me is Chris Kroll. He's also a product manager. And later on, we're going to have Arun. He's our engineering tech lead. He's going to come up to answer some questions. We have a ton of stuff to cover, so we're going to kick it off. So I'm just going to start with why enterprises use Service Mesh. What are some of the main key use cases and how that correlates to some of the products that we're building. We're going to introduce something new today called Cloud Service Mesh. We're very, very excited. You guys will be the first one to kind of openly hear about it. And then we're going to talk about some of the evolution of how we got here, where we're going. We're going to talk about some of the interesting and exciting things like what is Ambient Mesh, what is our strategy in Ambient Mesh, what does the API landscape looks like, where are we headed with that, with gateway APIs and other types of APIs. What is our story with data plane extensibility? Pretty much every single call that I'm on with our customers, they talk about what is your strategy about putting custom code in data plane. We're going to talk about Istio, and how Istio and the commercial products sort of relate, and what is our commitment to Istio. And then maybe showcase a couple of demos, a couple of new things that are coming. So we got a lot to cover, so let's kick it off. So first and foremost, there are three main reasons, in my opinion, why enterprises use or should use Service Mesh. One is if you are building scalable, globally scalable, and reliable applications in the compute runtime and infrastructure of your choice, you need Service Mesh. Service Mesh makes service discovery automatic. It makes service-to-service routing, regardless of which runtime you're sitting in. Second is if you're running these sort of highly dynamic microservices environment, again, in this heterogeneous stack, how do you do security? You need a policy framework. This is what Service Mesh provides, as well as policy enforcement points at the service layer. So no matter how your services are moving around, your actual policies remain intact. This is how you get to zero trust network. And then finally is just this sort of umbrella of service management. And I put sort of two things under that. One is this idea of telemetry, getting service telemetry both globally and being able to sort of go granularly within that. So that's logging, metrics, tracing, setting up SLOs and alerts. And the second one is advanced traffic management. And that's about, how do you safely roll out new versions of your services, using something like Canary upgrades or Blue-Green, or also how do you safely roll back? Right, so these are sort of the three tenets of Service Mesh. But like everything, with great power comes great complexity. When we look at our open source sort of landscape of Service Mesh, Istio obviously being one of the most prevalent Service Mesh projects that are out there, we still don't see it massively adopted. And we believe that there are three reasons for that. One is that it's fairly complex. You have to manage the lifecycle. You have to onboard it yourself. All the componentry that goes inside of your environment, you have to manage them yourself. It's sort of a DIY situation. It's also unsupported. You either have to get support elsewhere, or you have to figure out how to get support yourself, or you have to hire engineers to provide that level of operations. And then the third is the project itself. No matter what technology you pick, you're thinking about, does this have longevity? Does this have extensibility? Is this reliable? Can I use it in my enterprise business? Is it enterprise grade? Right? So you're really just reliant on the strength of the community. When we look at Google Service Mesh products, there are two products that we have today from a Service Mesh perspective. Some of you may have heard of something called Anthos Service Mesh. So that's the Istio API compliant or Istio-based enterprise-grade product. It works on both GCP and non-GCP environments. We have a managed version and a non-managed version. And it's really tailored towards a platform admin or an application operator persona. We have another product called Traffic Director. How many people have heard of Traffic Director? Okay, quite a few people. So Traffic Director is a GCP proprietary product, uses GCP APIs, works across all compute runtimes, works in Google Cloud, and it's really targeted towards a network admin. These two products have coexisted for a time, and over time they've sort of started to encroach on each other's space. They both provide Service L7 network capabilities, and that started to get a little bit confusing. And our customers ask, why can't we get certain things that one provide in the other products? So for example, why can't we get a global control plane with Istio-based APIs? Right? Or why can't we get multi-runtime support? And I don't want Istio-based APIs because I'm not in Kubernetes. So pretty psyched and jazzed to pre-announce the new product that we're coming out with. It's called Cloud Service Mesh. It is actually a convergence of both products. It's sort of the best of both worlds. It's going to be called Cloud Service Mesh. We're going to talk a little bit more about that. It is a globally scalable, fully managed, Google Cloud Platform Integrated Service Mesh for all enterprises. That's a lot of words, so I'm going to break it down a little bit. So globally scalable, we offer a global scalable control plane that can extend and run in any environment, whether it's Google Cloud or non-Google Cloud. One of the things we're really focused on is being fully 100% managed. So that means we manage the control plane and all the life cycle. We manage the data plane. We manage integrations with cloud networking, dashboards, and such. The third thing we're really, really excited about is that it is going to be deeply entrenched and integrated with Google Cloud's networking features that you guys are already using. This has always been a challenge with Service Mesh, and how do we integrate that with all of the other features that Google Cloud Networking provides? And finally, we're really focused on making it enterprise grade, right? So enterprises can actually use it. It's not just some science project that you put on top of your services that you have to manage. So we're focused on things like security, reliability, scalability of the product. And we're focused on those use cases that really matter to enterprises. So I'm going to invite Chris. He's going to talk a little bit more about how we got here.
OK, thanks, Samir. What I want to dive into a little bit is what Service Mesh looks like in your environment. Where does it fit? How does it play? So let's first start with your services, your workloads, because that's where we should always start, right? Customers deploy those on VMs. They may deploy them on Kubernetes environments, on GKE, or they may want to move to a serverless environment like Cloud Run. And then, of course, you've got to get traffic back and forth between those services and from the internet into those services. So Google has a variety of load balancers, level 4 load balancers, network load balancers, or L7 application load balancers, security proxies. We have a variety of networking products that make that happen. So where does Service Mesh comes in? So now that you have your workloads deployed, you want to use some of those features that Amir talked about. You want security on those workloads, or you want to do failover and load balancing between them. So now you want a Service Mesh. It's made up of two major pieces. One is the control plane. So as Amir mentioned, we are using Traffic Director. That is the global control plane across Google Cloud. It supports two sets of APIs. Very broadly, one is the open core APIs. So these are Istio APIs and gateway APIs. Sometimes you'll hear Gamma, which is gateway API for Mesh. So those are the open APIs, and we support those. We also have the Google-specific APIs, AppNet or service routing APIs that span the infrastructure. So they work on VMs, they work on Cloud Run, they work on Kubernetes. So that's what the mesh looks like. And of course, you don't want the mesh to be just some bolted-on thing. You want it integrated into the enterprise. So customers have really told us they want this integration in GCP. So we'll be doing a lot of integration with other networking components. This has already begun. But things like DEP, the Data Extensibility Platform, allowing Envoy filters, service callouts, things like that. Managed global rate limiting, and global load balancers integrated with the Service Mesh. Also centralized health checking and managed identity. So how do you get a consistent identity across your mesh? Again, across all these workloads. And then as we move forward, integration with AppHub. So if you haven't heard about AppHub yet, there was a session this morning, and there's another one coming up later in the week. AppHub is focusing on services and applications and managing at that level, trying to abstract away the infrastructure. So we will be integrating with AppHub going forward. And then finally, you want Service Mesh to be across all the places where your workloads are running. So that means on-prem and on other clouds. In that case, our control plane is Istio-D, so leveraging that open source investment. We have envoys and gRPC proxies, and this works, again, across several different kinds of workloads in that off-GCP environment. OK, so the things to remember specifically from that slide that got very complicated. We have multiple runtimes. We have GKE, GCE, and Cloud Run, different places where you can run your workloads. We have a control plane on GCP Traffic Director, off GCP Istio-D, and we support open APIs, open core APIs. And finally, more integration with the platform. Those load balancers, the extensibility platform, all health checking, all those things that I've talked about. Oops.
Yeah, I can talk about that. All right, so let's take a sneak peek into just the CSM architecture components. It's actually not a lot different than other mesh components. So you have a control plane. Again, as Chris mentioned, it's a globally scalable control plane on GCP that extends off GCP. We'll talk a little bit more about that. We have a data plane, and there are multiple modes of data plane, and we'll talk about what some of those are. And then you have these other CSM mesh services that augment the mesh in some form or fashion. So for example, a managed certificate authority, the integration with our cloud ops and services dashboards and other GCP networking services that we'll talk about. And then we have a myriad of surfaces that you can deploy these through Terraform or through a G-Cloud API or through the UI itself with just a checkbox. So let's just double click a little bit further into each of these. So from a control plane perspective, on GCP, it's always going to be hosted and always going to be fully managed, which means we manage the lifecycle for you, and it's globally scalable. So it's a single control plane that extends everywhere. It offers both Google and Istio APIs. Off GCP, it will be local, however managed by Google, and it will only offer Istio APIs off GCP. For data plane, there's a lot going on in this slide, so I'm going to break it down. On the left-hand side, everybody's familiar with the sidecar mode. That's sort of the most common mode where a proxy gets installed alongside every single workload. It's a full-blown L7 proxy, whether you need it or not. So if you're just doing L4, just using it for MTLS, it still gets deployed. It has this shared fate model. So when you're managing lifecycle of either your application or the proxy, the entire thing has to get rebooted. It's been working really well. It offers this client-side model, much more granular control over your traffic. On the far right-hand side, you have sort of the opposite end of the spectrum, which is gRPC proxyless. No proxy gets used. If you're a gRPC shop, you can use CSM control plane to manage that. In a lot of cases, you may get 80, 90% of the way there by having almost no control plane resources, whereas the sidecar mode can get sometimes resource intensive. In the middle, we have Ambient. I'm going to talk a little bit more about that later, but just to give you a sneak peek, it's this idea of that a mesh can be L4 or L7, and you get to pick and choose which one you want to use. And you can even sort of graduate from starting with L7 or L4 to L7. It's sidecar-less, and we'll talk a little bit more about how that works. So CSM will support all three. And then from a mesh services perspective, we have managed CA or managed certificate authority, whether you want us to manage the root on your behalf, so it's fully managed. This is for your workload certificates, or you want to manage the root, so we offer both. And then we have tons and tons of integration. So as I also mentioned, services dashboard, security insights, SLOs and alerts will continue to happen. Our cloud ops integration with logging, tracing, custom dashboards you can always create with custom metrics, policy controller integration to create that zero trust network.
Thanks. Okay, so we've given you an idea of what CSM is. So a lot of you in here today are current ASM or TD customers. So let's talk about what that means to you. So first off, we're announcing CSM today. The product will actually launch to GA in 5 or 6 weeks. This is the current timeline. So you will see a blog announcement coming out soon. But for current ASM customers, when we launch, what does it mean? Well, you're using Istio-based APIs. You have a managed control plane, a managed data plane. You're using either Mesh CA or CA services. You have the UI. What's going to change is over the next 2 to 3 quarters, those clusters with managed control plane will be migrated to Traffic Director control plane. And that's the extent. You still get to use these same open APIs. You still get all the other managed services. What about ASM off GCP? So if you're running this on another cloud or on-prem, there are really no changes in the short term. You're going to continue to use the Istio APIs. You'll continue to have Istio-D in cluster. But what we will be doing in the future is moving to a more managed environment. That current off GCP environment has to be updated by you. We will provide an API to do the updating. So we're going to simplify that and remove the toil for you for managing those clusters. And finally, if you're a traffic director customer, there are no changes. So we talked about the AppNet APIs that Traffic Director uses to manage the endpoints on Cloud Run, on GKE, on VMs. Those APIs continue to work, so there's really no change for you going forward. Okay, so that's CSM. We've talked about what it entails, what it means for you if you're an existing customer. Now let's talk a little bit about where it's going. So what does the future bring? Okay, we've touched on this a little bit, but tighter GCP integration. We'll do more and more integration with the load balancers, with Cloud Armor, with IAP, with health checking. All those things will come as part of the platform. And as I mentioned earlier, customers have been clear with us, they don't want a separate bolt-on mesh. They want something that's integrated with the platform. So that's where we're going. APIs, we've talked about this, but I want to reiterate it. The open APIs will continue to be supported. We've invested in the Istio open source. We're going to continue to use those APIs. Things are also evolving, though. We're going to be moving to the gateway APIs. And then we have the APIs that have been built specifically for GCP, and those will continue as well. Multi-data plane support, so envoys, sidecars, whether they're running in a pod, a container in a pod, or whether they're running as an executable on a VM, whether it's integrated into Cloud Run, the Envoy sidecars are going to continue to be supported. We also have proxyless gRPC. So that enables customers to use a lower overhead model, again, controlled by the same control plane, still sending XDS configuration information to it, but it's built into the gRPC libraries. And finally, more integration with GKE. We're looking at how we can provide ambient mode. And with that, I'm going to hand it back.
Yeah, so Ambient, how many people have heard of Ambient, by the way? Istio World and stuff? Not too many. Okay, that's good. Maybe I can go a little. So Ambient Mesh is an architecture pattern. Different vendors will have their own implementation of this architecture pattern. So Istio has an implementation, and we will have an implementation. So what does that mean? Let's start at the beginning. So right now, with the sidecar mode, this is what the picture looks like. So you have a single cluster, let's say, with a couple of nodes, and there are some services running, and every single pod or every single workload gets this sidecar proxy installed. And through the magic of CNI and redirection, all the traffic gets routed through these proxies, and then you get these fancy features like authentication and encryption and authorization and so on. So what Ambient's model is that currently the sidecar provides both L4 and L7 feature functionality, like I mentioned, whether you need it or not. A lot of our customers just need service mesh for basic encryption. That is just a checkbox or a compliance reason where they need it, which is an L4 feature. You don't need this resource-intensive proxy alongside every single workload. So it splits the L4 and L7 features functionality into a couple of pieces. And then additionally, it also removes the sidecar model a little bit. So the problem with the sidecar model, in addition to being resource intensive, is that shared fate model. So when one gets compromised, the other is automatically compromised. When you have to upgrade one, the other must also be rebooted. So now you have this proxy sitting, and that just provides you with an L4 functionality, nothing else. So if you're just beginning your journey and you just need L4 features, this includes MTLS, encryption, identity-based encryption, L4 telemetry, you're done. You can just do that. It's much less resource intensive. It's much more performant to be able to do it this way. If you need L7 feature functionality, this is where you move to the full-blown L7 ambient mesh model. And this was what it would look like. So you notice that we've even removed the L4 proxy. So in Google Cloud, the ambient mesh architecture implementation would look something like this. The L4 functionality will get relegated down to the GKE data plane, or the DPv2. So that will just inherently provide you with the MTLS and L4 functionality. And then all the L7 functionality has also been stripped out of the cluster, and now it resides in Google load balancers. Chris sort of mentioned that we're going to be tightly integrating with Google load balancers. So you can think of them as managed proxies or ILBs, which are much, much more scalable than sidecar proxies. Now the only thing that remains inside of your cluster is your services, which is what we want you to manage. So you can sort of kind of see why we call it the ambient mode, is that the mesh sort of starts to disappear and dissipate into the infrastructure, and all you do is just simply use your features of the mesh. Chris is going to now talk about some of the API stuff.
Okay, we've mentioned this before, but again, it's important, so I want to make sure we cover the open core APIs, specifically the Istio APIs that are in use today. We will continue to support those. As I mentioned, we'll continue to invest in Istio to the open source project, but we are also going to become more opinionated. There are a set of Istio APIs that are experimental or alpha, and they've been in that state for some time. We don't feel those things are really ready for production, so we're going to become more opinionated and focus on supporting the beta and G8 APIs of Istio. Secondly, the Google APIs, again, we'll continue to invest in those and improve those as we go along, supporting those infrastructures on GCP, the VMs, GKE, Cloud Run. And finally, Gateway. Gateway seems to be the magic answer for everything when questions come up. But Gateway is obviously a Kubernetes method for getting in and out of the cluster. This is the new model instead of ingress and egress. And this is being extended to the mesh through the Gamma working group within Kubernetes. So it's a vendor-neutral approach to managing Kubernetes environments being extended for the mesh. One of the nice things about those gateway APIs is they can be extended. That's how we're getting Gamma. But vendors can also extend them. So if we have specific GCP features that we want to add to those APIs, we can do that through the gateway API as well. Data plane extensibility. So Istio and Traffic Director and ASM, they all have a wonderful set of features. Sometimes customers complain that they're too complicated, there's too much functionality, and they're not sure how to use it. But we also get another set of questions about, hey, I want to do something special. How do I extend it? I want to do some extra authorization checks. I want to do some extra logging for debugging, or one of the things we frequently get is I want to change headers. I want to insert a new header or change something that's there. So when we look at extensibility, there are a couple things that we look at. So first off is the use of WASM. So WASM is WebAssembly. So it's a way of creating a module that can extend the functionality, and it can be implemented within the Envoy proxy itself, or you could put it outside Envoy and call out to it. So WASM is the standard approach we'll be using as we go forward. It supports multiple languages, and eventually we'll get to a point where there will be WASM modules that are common, may even show up in the marketplace. Another approach to extensibility is through callouts. So Envoy has this external processing interface, XProc, and from there you can call out to, again, an authorization service or something else you want to do. And then finally is Envoy filters. Now, Envoy filters are kind of one of those alpha features I mentioned earlier. We don't currently support Envoy filters, but we know a lot of customers are using them. There's some common functionality in there. Again, header manipulation, data compression, things like that are common that people do want. So they use Envoy filters. Our approach is going to be, first off, we'd rather have a first-class API, so working with the open source to get it implemented as an API. If that doesn't work, what we're going to do is look at testing and supporting a small set of filters. So again, some of those common use cases that come up over and over again, we will be supporting those as we go forward. But it's going to be a small set, not everything.
So the biggest thing I think might be a surprise to you is the move away from Istio-D from the control plane perspective and move to Traffic Director. So maybe some of you are thinking, you know, what does that mean for our commitment to Istio? So I wanted to talk a little bit about Istio and where we are. So what is Istio? Istio is an open source service mesh project, probably the most prevalent one in the industry, very widely used. It is unsupported, and it is sort of self-managed DIY sort of an approach. It has tons and tons of features. You can do tons and tons of things. And we kind of split those features into two categories, sort of safe for production or safe for work features, and then maybe not safe for work or not safe for production features, so like alpha features, experimental features. It's got the API compatibility, the Istio v1 APIs that everybody likes. And then you have CSM. On the opposite end of the CSM, the idea is that it has to be fully managed, where you don't have to manage on any of the components of the mesh itself. You are consumers of value. You don't need to worry about how to actually create the mesh. It is fully supported through Google, and it is enterprise ready, which means it's safe for you to use no matter what features there are. So there's an overlap, right? So we provide API compatibility between the two, so you still get the portability, and we have all the features that are supported. But what we're really focused on are these enterprise-grade features that everybody is really wanting, right? So globally scalable control plane that is at the scale of Google's load balancers, our GCP networking integration that Chris has been talking about, a data plane extensibility solution that we just went through, other integrations with CloudOps, the pre-built dashboard, so you don't even have to worry about it. You can just simply set SLOs and alerts and go about your business. Multi-cluster ingress and multi-cluster gateway support, policy controller integration with our managed gateway, multiple runtimes and data plane modes that we're introducing with gRPC and Ambient, and then so on and so forth. So the idea is that move to it is really for better GCP networking integration and better scale. An analogy that I always give is Istio is like this fixer-upper home. You can get it for very, very cheap, but you better know how to knock down walls and build kitchens and bathrooms and stuff. It's going to take a lot of operations. And customers that are using it successfully are contributors to the project, and they have dedicated operational resources just to manage Istio themselves, and they're getting really, really good value out of this. Versus CSM is sort of this move-in ready home. It's fully furnished. You come in, and you just live. And that's what we're really sort of building. So Chris, you're going to talk about where does CSM actually run?
OK, so CSM, again, the multiple control planes, traffic director and Istio-D. So traffic director on GCP. So looking at this slide, Google Cloud is going to be focused on traffic director with the open core APIs and with the G-Cloud APIs. CSM will also run on other environments, other public clouds. It will also run on-prem through GKE Enterprise, and it will be integrated with GDCE and GDCH as we go forward. So what we are trying to do is provide a service mesh that spans your whole environment and gives you the functionality you need there.
All right.
You're gonna, yeah.
OK, let's take a look at a couple of new features. So the first one was multi-runtime support. A lot of people were asking that. Nobody pretty much runs their applications in a single runtime. They're always running in different runtimes, so we added all of the runtimes. So the architecture, we have all three runtimes, Cloud Run, GCE, as well as GKE. We have a client service running, that's the service A in Cloud Run. So from Cloud Run, we're going to hit all the other services. And we have another service running. It's just going to be a Hello World service, that's service B, that is scattered across all three runtimes. So there's a version running in Cloud Run, there's a version running in GCE MIGS, and then there's also a version running in GKE. So we're going to see kind of how that works. So we've just videoed it for the sake of time, because Terraform sometimes takes too long. I apologize for the small text, but I'm going to try to explain what is happening. So first and foremost, just to explain the environment, so at the bottom right-hand side, left-hand side, you will see the GKE cluster. We have an autopilot cluster with mesh enabled. And right under that, we have this HTTP route in the middle. And that HTTP route is only going to one destination or one host name, and I think it's just hello.mesh. And then it has three destinations. They're all commented out in the middle of the screen, right? So it has a module for MIGS, so that's the GCE Managed Instance Group, module for Cloud Run, and a module for GKE. And we're going to deploy it one at a time, and we're going to uncomment those. And then we also have this service A running. That's just the curl service that we're going to use, and it's running in Cloud Run. So the first thing we're going to do, and right now we don't have service B running at all, so we're going to uncomment the MIG module. So that is going to deploy that Hello World service version 1 in a managed instance group with 2 VMs. So we just did a Terraform apply here on the other side. And you can see that that's being deployed. We're also going to uncomment the destination from the HTTP route for that MIG. So as the VMs are being deployed, we're going to update the HTTP route for that thing. We're going to do another Terraform apply. And on the bottom right, you'll see that there's a curl going, and right now it's just 503s. And as soon as the MIGs get deployed, you can start to get responses from version 1, and it's bouncing between 2 destinations. The next thing we're going to do is uncomment the Cloud Run module. So that's going to deploy a service in Cloud Run. And again, we're going to do a Terraform apply, and then we're also going to uncomment the destination, the Cloud Run destination from the HTTP rule. And now you'll see at the bottom right where the curl is, now you're getting v1 instance to the 2 MIGs as well as hello run. So now you're bouncing between the 2 runtimes. And then the last thing we're going to do is we're going to take the GKE module and uncomment that. That's just going to deploy a service and a deployment. So it's pretty basic stuff. This is running v2 of that service, just so you can visually see something different. And we're also going to uncomment the destination from the HTTP route. So we now have all 3 destinations uncommented from the single HTTP route. We're going to deploy that. And again, if you are observing the bottom right curl, you're going from v1, 2 instances on GCE, 1 in Cloud Run, and now you're getting v2 from GKE. So now you're load balancing through the same service across all 3 runtimes. Chris is going to talk about gRPC next.
Okay, we have another short demo based on proxyless gRPC. So this is a very simple one. It's very short. There are 3 services here. The one in the middle is really just an echo application. So what we're going to do is deploy that and then show both Service C and Service A talking to it. Service C is another GKE workload on the same cluster. And then Service A is actually a Cloud Run service talking to this. Okay, so most of the action here, again, I'm like Amir, I'm sorry for the small font. It's probably tough to read. Most of the action is going to take place on the right side. So we've deployed the first service, and we're going to get the route so you can see what that looks like. So this is done with the Gateway API. So configuring the route to get to Service B. And then we are going to deploy Service C, the other GKE service. So that will be in the upper right-hand side. Okay, we check the pods, they're running. Now we do the port forward command and call Service B, and you will see the output in the lower right. Okay, so all it did is call Service B with 100 separate RPC requests. Okay, now we're going to move on to Cloud Run, again in the upper right-hand side, and we're going to deploy that Cloud Run application and have it do essentially the same thing. Call that echo application with 100 RPC requests, and again, you will see the output on the lower right. Okay? So, very simple little demo, but it shows you can use gRPC as one of the data plane components, and it works on a variety of infrastructures. Okay, so to sum up, where are we going? Where is Mesh headed? First off, more runtimes and infrastructure, supporting all the infrastructures on GCP, VMs, containers, both in clusters and in serverless environments, multi-network support. So just more and better integration with the platform. App Hub, as I mentioned, is coming. Data plane extensibility, the managed load balancers, health checking, cross-cloud networking, all these features come together to give you a fully integrated platform with service mesh capabilities. And finally, what we want to do is up-level the conversation to services and applications, not focus so much on the infrastructure. We want Google to take care of that for you so you don't have to worry about it, where you can focus on the place where you add value in your own services and applications. Okay, a little housekeeping. You've probably seen this in earlier sessions. There are more offers you can get from Google Cloud. Specifically, there are other sessions I would ask you to take a look at, though. The first is Cloud Run. There's a session tomorrow on what's next with Cloud Run. So there'll be some mention of mesh in that topic. Second is a security session. So where are we going with workload identities and CAs? So this is a critical thing across your infrastructures. If you want MTLS working across Cloud Run, GKE, VMs, you need identities that can be trusted across those different environments. So we have a session that will be Thursday at 1:30. And then the final one is App Hub, and unfortunately that one happened this morning, but it was recorded, so you should go take a look at the App Hub session as well. And then finally, any feedback you have for us, we would appreciate.